Let's start with the very first topic in our system design course, that is scalability. So what is scalability? Let's read this complete document to understand what it is. So as system grows, the performance starts to degrade unless we adapt it to deal with that growth. Okay, that means every system, if we work on a system day by day, the performance will get degraded if we don't work on its growth. Suppose scalability is a property of system to handle a growing amount of load by adding resources to the system. That means day by day in our current system, resources may increase, data may increase, anything can increase. So based on that, we need to scale our systems. That means the scalability, what it will do, it is property of a system to handle a growing amount of load. Suppose if that load can be any kind, if a growing amount of load, if you should handle that, we call as scalability by adding resources to the system. So two things are important. So if there is a load on the system, if there is a load on the system, if that load increases, we should add the its related resources. That means if there is more data that is incoming, suppose our total capacity is 100 GB, and whatever data accumulated so far may cross this 100 GB, then we need to extend our hard disk to 100 more GB hard disk. So in that way, what we did, we have increased our memory resource. This is hard disk is also a resource, we increased it. So this is the way. That means how we are handling the load is called the scalability, how we are scaling the system. This is called scalability. Okay, then a system that can continuously evolve to support a growing amount of work is scalable. Okay, in this article we will explore different ways a system can grow and common ways to make a system scalable. So we understood on a high level, in a nutshell, what we understood, if load increases, we should increase our resources to make our system scalable. So let's understand what are different kind of loads and what are the different kind of resources we can use. If you are okay, suppose how can a system grows? A system can grow in several dimensions. Okay, system can grow in several dimensions. That means more users, that means more number of users visiting to the website or the app, more features, if we are adding upon more features, as we discussed, more data, and also more complexity. That means lot of logic is getting added, which really requires more CPU, and also more geography. That means we are extending our website accessibility to all over the world. So let's understand each of the case where the system load will grow. So this is load. Here the system load will increase. First one, growth in user base. More users started using the system, leading to increased number of requests. Okay, more requests will come. In that way, load will increase. Example, a social media platform experiencing a surge in new users. Next, growth in features. More features were introduced to expand the system's capabilities. Like in the WhatsApp, we can observe lot of features are adding day by day, and they need to scale up their system based on their features as well. Example, an e-commerce website adding support for a new payment method. That is fine. Okay, next, growth in data volume. Growth in the amount of data the system stores and manages due to user activity or logging. Okay, the amount of data system stores and manages due to either user activity or logging. We should log user logging, or that can be of any data. Example, a video streaming platform like YouTube stores more video content over time. Okay, so this is based on the user uploaded videos data volume. Growth in complexity. How? The system's architecture evolves to accommodate new features, scale, or integrations resulting in additional components and dependencies. That means, example, a system that started as a simple application is broken into smaller independent systems. Okay, that means growth in complexity means, suppose if there is a system that has all these things, like it has a car, it has checkout, it has user profile, like this. Suppose if we day by day its complexity is growing, that means in the checkout or cart we can maintain a separate service for this whole logic. Okay, that is called that is called system architecture. Actually, the whole complexity we are dividing into microservices. So each service, that whole architecture should be accommodate new features, it should be scalable, it should accept incoming integrations. Okay, as simple is broken into smaller independent subsystems. Okay, growth in geographic reach. The system is expanded to serve users in new regions or countries, as we discussed. A e-commerce company launching websites and distribution in new international markets. Suppose if you started an e-commerce website in India, if you want to expand it in US, what we should do? That is also one kind of incrementing the load. Here also load will increase. So how are we handling that? Okay, next we understood how this load will happen in a system. There are like 5 ways. Users, what are those 5 ways? One is user base, one is features, one is data volume, and one is complexity, I mean microservices, and another is geographic reach. Next, how can we scale a system? Here are 10 common ways. There are 5 ways of load and 10 ways to make a system scalable. That is, first is vertical scaling. Okay, this is a very new term we are learning. What is vertical scaling? This means adding more power to your existing machines by upgrading server with more RAM, faster CPUs, or additional storage. It's a good approach for simpler architectures but has limitations in how far you can go. So vertical scaling means directly improving. Vertical scaling means, suppose you have 4 GB RAM but your system should handle more requests. That means your RAM should work like 16 GB. In that case you need to upgrade to 16 GB. That is how we have scaled up our system. Like that, either we can upgrade CPU wise, or we can upgrade RAM wise, or additional storage as well. And from the picture we have upgrading to bigger system. It's more like whatever existing is there, we are just upgrading it. Next, horizontal scaling. Our second method of scaling is horizontal. So for vertical scaling we call it as scale up. What is this? Scale out. This is scaling. Horizontal scaling, that means scale out. This means adding more machines to your system to spread the workload across multiple servers. Here, instead of having a single server, we should maintain multiple servers. Okay, that means if a request comes, it should go to multiple servers: server 1, server 2, server 3, and server 4. All these servers same work. Okay, this means adding more machines to your systems to spread the workload across multiple servers. Okay, it's often considered the most effective way to scale for large systems. Okay, vertical scaling is for smaller systems and horizontal scaling is for larger systems. Example: Netflix uses horizontal scaling for its streaming service, adding more servers to their clusters to handle the growing number of users and data traffic. So Netflix uses this. Netflix, where it is using in streaming. So in streaming, what it is doing, it is horizontal scaling. That means if more numbers came to watch the live, then it is scaling it horizontally, scaling its servers. So to handle growing number of users and data traffic. Next, third one is load balancing. We covered uh, vertical scaling and horizontal scaling. Let's check what is a load balancer. Load balancing is process of distributing traffic across multiple servers to ensure no single server becomes overwhelmed. Suppose, what is difference between horizontal and load balancing? That horizontal scaling is you are making same work in two in multiple servers. That is horizontal scaling, but spreading the typical request to whatever available server is there. That is called load balancing. So load balancing comes before the scaling. So this is horizontal, this is load balancer. So both works combinedly as per our understanding so far. Load balancing is a process of distributing the traffic. It will distribute the traffic across multiple servers. Multiple servers is already by horizontal scaling to ensure no single server becomes overwhelmed. That means overloaded. Okay, suppose this is the client. This is the load balancer. Suppose if we call this as load balancer, what it will do, from client if a request came, it will process something inside the load balancer and it will pass that request. Example: Google employs load balancing extensively across its global infrastructure to distribute several search queries and traffic evenly across its massive server farms. Okay, Google uses more. So Google is using load balancing. What it is doing, it is distributing search queries and traffic. Suppose if user entered any search query in Google search, if user enter any search query, it is passing that to load balancer and load balancer is passing to whatever available server is there to that. And next, fourth one is caching. How can we scale? How can we scale our system using caching? So caching is a technique to store frequently accessed data in memory like RAM to reduce load on the server or database. So if a load comes up, we can vertical scaling, horizontal scaling, or load balancer. All these techniques will really help in scaling. And now this caching will do, what this caching will do, we will store most frequently accessed data. We will store most frequently accessed data and return that to user. So this way also we can reduce the load. That means our system, we can call it as scalable. That means if you add any caching to your system, add cache to system, means it is scalable. Caching is a technique to store frequently accessed data in memory to reduce load on the server or database. Implementing cache can dramatically improve response times. Okay, this is an application. Generally it will ask directly database But instead, if we store in the cache, it will ask the cache and it will return the data. If any cache is missed here, then it will ask the database. Okay. Reddit uses caching to store frequently accessed content like hotspots, hot posts, and comments so that they can be served quickly without querying the database each time. Okay, so Reddit is using it. That means if any users most frequently most frequently visited posts are there, Reddit is storing that in a caching system. So all the posts, that comments also come from the cache. CDNs. How can we use CDNs to make system scalable? CDN means content delivery network. That means there is a network which delivers the content. CDN distributes static assets, that means images, videos, closer to users. This can reduce latency and result in faster load times. Okay, suppose in your system, if you keep on adding videos or photos, they will take really lot of time to load. What this CDN will work, it will distribute static assets. That means it will already load these videos and it will pass that. Here the content means the static assets. Cloudflare provides CDN services. Okay. So suppose if user visit a website, suppose this video or pics taking 10 seconds to load. So every time if user visit 1, visit 2 and visit 3, if we see 10 second lag, he is no more interested in our website. So suppose if we visit first time, if we take 10 seconds, that is fine. From second visit onwards, this will be loaded from the CDN. CDN is also acts as a cache. Okay. Now, how we can use CDN in our website? Cloudflare will provide CDN. Cloudflare provides CDN, content delivery network services, speeding up website access for users worldwide by caching content in servers located close to users. Okay. And generally the CDNs works like it will store the data, it will cache the data, very important, cache the content in servers located closer to users. Okay, suppose in this image, this is original server, this is CDN, this is CDN, this one, and these are users. Suppose if users ask an asset, it will not load from here or here, it will load from its nearest CDN. Next, sharding or partitioning. So how can we scale our system? One more approach is sharding or partitioning. What is sharding or partitioning? Partitioning means splitting data or functionality across multiple nodes or servers to distribute workload and avoid bottlenecks. Okay, sharding is nothing but a partitioning. What is partitioning? Generally, if data is more, we will split it, or functionality, we will split the functionality across multiple servers. We will call it as partitioning, maybe like micro services. Okay, horizontal scaling. Horizontal scaling is also more similar. Let's check sharding. Suppose A to Z is there here. Okay, horizontal scaling means we are copying every server from S to S1, S2, S3, kind like that. What is this? This is horizontal. Okay. What is sharding here? Here actually splitting. That means the single server will be splitted into subservers. Example, Amazon DynamoDB. Okay, Amazon DynamoDB. That means this is a database. Uses partitioning to distribute data and traffic for its NoSQL database service across many servers, ensuring fast performance and scalability. Okay, this partitioning is the DynamoDB will DynamoDB. So DynamoDB will allow us to distribute data. So it internally it will allow us. So we can remember if in any database we can split, that we can go for DynamoDB. Uses partitioning to distribute data and traffic. So it is one of the technique. Partitioning is one of the technique that DynamoDB is using. Next, asynchronous communication. Asynchronous communication. Okay, this is one of the approach. What is my communication means? Deferring long running or non-critical tasks to background queues or message brokers. Okay, suppose if a task is taking lot of time or long running and also low priority tasks to background queues, that means meanwhile that is running some you can start some another task meanwhile the task is running which is long, or message brokers. How can we achieve that? We can keep that low priority tasks in a queue. This ensures your main application remains responsive to users. Okay. Slack uses asynchronous communication for messaging. When a message is sent, the sender's interface doesn't freeze. It continues to be responsive while the message is processed and delivered in the background. Okay, where we are using this? So Slack is using this. How it is using? Suppose a user send a message. If it is really taking a long time, that message should reach the server, and that from that server it should reach the recipient. So for all this process it will take some time, but we shouldn't stop the user to use the Slack. Okay, for that we will make this as asynchronous. This whole process is asynchronous. That means this will work in the background. This will continue. Next, microservices architecture. Microservice architecture breaks down application into smaller independent services that can be scaled independently. Okay, scaling up complete website is one approach, and also scaling multiple servers is another approach. So we will break down the application into smaller independent services that will scale independently. This is important. Okay, so this improves resilience and allows teams to work on specific components in parallel. Okay, if there are microservices, definitely each team, separate teams can work on separate microservices so that they can scale independently. Suppose this is okay. If there is only one service, we call it as monolith. This is the one terminology. If we use it as if we split it into one or more, two or more microservices, we call it as microservices, and we don't call it as monolith. Mostly large systems are like this, microservices only. Uber Uber has evolved its architecture into microservices to handle different functions like billing, notifications, ride matching, allowing for efficient scaling and rapid development. Okay, suppose in our entire application few things are maybe crucial. If we make it as a separate microservice, we can scale it independently. So that is what Uber is also doing. Next, ninth approach is auto scaling. What is ninth approach? It is auto scaling. Auto scaling means automatically adjusting the number of active servers based on the current load. How this is possible? Adjusting the current number of active servers based on the current load. Okay, let's see. This ensures that the system can handle spikes in traffic without manual intervention. Okay, without manual intervention also the system should be scalable. Example, AWS auto scaling monitors applications, auto scaling monitors applications and automatically adjust capacity to maintain steady predictable performance at the lower possible cost. Okay, what is this auto scaling? Okay, automatically adjusting the number of active servers. So whatever servers are there, in between them only the current load should be adjusted. Not we are doing anything extra, but in the active servers only the current load should get adjusted. That too automatically. For that we should have some algorithms that we call as auto scaling. This ensures system can handle spikes in traffic without manual intervention. Okay, and AWS auto scaling monitors applications and automatically adjusts capacity to maintain steady predictable performance at the lowest possible cost. Okay. Next, multi-region deployment. What is this multi-region deployment? Deploy the application in multiple data centers or cloud regions to reduce latency and improve redundancy. Deploy the application in multiple data centers or cloud regions to reduce latency and improve redundancy. Spotify uses multi-region deployments to ensure their music streaming service remains highly available and responsive to all users over the world, regardless of where they are located. That means multi-region deployment is, suppose Spotify wants to work in all over the world, it should be responsive to users all over the world. At that time, what it should do? It will deploy its actual code. It will deploy its application in multiple data centers. That is called multiple region deployment. And cloud region, so that only that region people will access the nearest data centers and not the actual data center. And it will reduce latency and improve redundancy. Okay, thanks for joining. But let's recap all the topics once. So today we understood what is scalability. So on a high level, what we understood, scalable means system should update or evolve with its growth. So in the scalability, system should evolve or update with its growth. That means we should scale our system. Whatever system we are designing, that should be scalable. Okay, so for that scalability there are two things. How can we scale? First we need to identify at what areas the system needs to be scaled up. There are 5 areas. If it is more users, more features, more data, or more complexity, or more geographics. So in all these 5 scenarios, our system will grow. And next, and how we can grow our system. There are multiple approaches, multiple techniques. That is vertical scaling. We will just scale up our existing servers. Horizontal scaling, that means we will add more machines uh, uh, that will to spread workload across the multiple services. Okay, the same service we will just add multiple servers. Load balancing, it will distribute the load to across multiple servers. What is caching? We whatever frequently accessed data is there, we will add that cache that to the cache, so that it won't becomes a load to our system. So drastically our system will be scalable. And using CDNs, whatever content that is taking more time, we will store that in the nearest network, so that it won't take much time. Drastically the load will decrease, and scalability performance will increase. And next, sharding or partitioning. So we are sharding or partitioning means we will split a functionality or data into multiple nodes or servers. Then asynchronous communication. Asynchronous means any process which will take more time, we will keep that in the background queues and enabling the user to move forward. In that way also our system should be scalable. And microservices. And microservice means it should not be a monolith. If we split our complete application into multiple services, it is called microservice. Auto scaling, and if we make it microservice, at microservice level we can scale it up. And auto scaling, within the active servers the system also should automatically adjust its current load. Next, multi-region deployment. When multi-region deployment, we already learned that the complete application should be deployed in the different data centers that will handle latency and redundancy. So I hope you understand what is scalability in the system design. So what is scalability, and what are the factors that should be considered that will affect the system, and how we are handling that, and how we are handling the different kind of loads, and handling with different approaches. Thanks.